Its name is Arun's Idea, and my name is Arun. I am from Tamil Nadu. In this channel, I am going to post some videos which are asked in JEE Advanced, and we are going to discuss some concepts. And these videos will be giving you some ideas clearly, and it will be step by step. In this video, we are going to discuss a question which is asked in JEE Advanced 2023. This will be the idea behind this video. Let's dive into the problem without delay. A particle of mass m is moving in the xy plane such that the velocity at a point xy is given as v vector is equal to alpha y x cap plus 2x y cap, where alpha is a non-zero constant. What is the force acting on it? There are four options A, B, C, D are given here. Okay, it's given that a particle m. We are given a particle and we are asked to find the force on the particle. If it is force on the particle, we can use the Newton's second law for particle. I'm mentioning it again and re-emphasizing it is a particle. What is force on the particle? It is m into a vector. So mass times acceleration. This is a formula that we do know, everyone. So what is a vector? A vector can be written as, so this problem, the motion happens in the xy plane. So we can write the acceleration in the Cartesian form only for x and y. Ax x cap plus ay y cap. It doesn't have any z component because the motion is in the plane. The motion is in plane. So the motion is in plane, therefore, which plane? It is in the xy plane. So there will be no z component of velocity. The z component of velocity is 0. Z component of velocity is 0 because it moves in the xy plane, which implies that when we differentiate the velocity in the z direction, it becomes, so we'll get the acceleration. The acceleration is also 0. Okay. So if it's not mentioned, it is a particle. Particle, if it's not told as a particle, so what will be a force? The force is equal to the rate of change of the linear momentum. Okay. So this leads to, we'll have a component of the change in the mass with respect to time. So here we are told particle, the mass is not going to change with respect to time. Particle dm by dt is equal to 0. So we want to find the force. It's asked. So what we have been provided with? We have been provided with a velocity. So what is velocity? We know the formula for velocity. Velocity is dr vector by dt. So it's been given here. What's been given? Alpha y x cap plus 2 alpha. Sorry, plus 2 x y cap. Okay, we can bring the alpha inside. So alpha y x cap and plus 2 alpha x y cap. So this is known as the x component of velocity and this is known as the y component of velocity. So we'll write it. The x component of velocity will be mentioned as Vx, that is alpha y, and the y component of velocity will be mentioned as Vy, and it is 2 alpha x. This is known as x component of velocity. This is known as y component of velocity. So then now we want to find the acceleration so as to we can complete the problem. So how can we find the acceleration? What is the acceleration vector? Acceleration vector can be written as dv vector by dt. So this is also equal to, in the Cartesian form, ax x cap plus ay y cap. Okay. So we will write I cap and J cap. In our books, we do have I cap and J cap. It can be also rewritten as X cap and Y cap. Okay. Now, what is AX? AX is equal to dVx by dt. AY is equal to dVy by dt. So, can we substitute Vx d by dt? And instead of Vx, we will be substituting its alpha y. And similarly, we can substitute Vy here. That is 2 alpha x. Okay. Can you differentiate it? So, Ax is equal to d by dt of alpha y. So it's told that it's very clear in the question. Alpha is a non-zero constant. It's not a zero value. It's not a zero constant. Alpha is not equal to zero and it's a constant. So what can we do now? We can remove the alpha outside and we can write it outside from the differentiation. So now we are left up with dy by dt. What is dy by dt? Dy by dt is vy, the velocity in the y direction. So we have compared and we have wrote what is Vy? It is 2 alpha x. 2 alpha x. So it becomes 2 alpha square x. Okay, fine. We have got the x component of acceleration. Now we'll move to the y component of the acceleration. We have done it here. So what is the y component of acceleration? Ay is equal to d by dt of 2 alpha x. I hope it's right. So now who are the constants? Can you remind? Yes, 2 alpha is our constant. So d by dt of x. So how can we do this? 2 alpha dx by dt is the velocity in the x direction. So now we have obtained the y component of acceleration. Finally, we can write the acceleration vector. What is our acceleration vector? Ax x cap and ay y cap. So what is the ax? Ax is equal to 2 alpha square. So sorry. Ax is equal to we have to substitute the Vx here. I didn't do it. So 2 alpha and what is Vx? Vx is alpha y. If I substitute this both 2 alpha square y. So this is my acceleration in the y direction. So I'll go to the next page to write the acceleration vector. So what is the acceleration in the x direction? 2 alpha square x cap plus 2. Do we have 2 here for the y component? Yes. 2 alpha square y cap. 2 alpha square y cap. So now we want to find the force. It's asked to find the force. We have found the acceleration vector. So what is force? We can substitute the acceleration vector here. That what we have found. So force is equal to f times a vector, ma vector. So I have to multiply the mass before this acceleration. How will I multiply? It is 2 alpha square x cap plus 2 alpha square y cap. If I multiply mass inside, what happens? So I will check the answer. What we have been represented as. Yes, we can take the similar terms which are there here. So here 2 alpha square and 2 alpha square is there. M 2 alpha square x times x cap plus y times y cap. Okay. So can you check, do we have such an answer? Yeah. The answer 1A is our answer for this question. Okay, sometimes yeah, we got the answer. Do like and subscribe our channel. Sometimes it might also be represented in such a way. You should be ready to do it. So force vector is equal to 2 alpha m. And if you look over this x cap and y cap, what is that? X cap plus y cap is the position vector. Position vector in the Cartesian coordinate system. So it can be also written as r vector. So r vector can be also written as r vector. So one thing I would like to emphasize: if it is an r vector, this is a this is what? This is an central force system. This is a central force system. The definition of central force system, it is what? It will be, the force will be directed along the direction of the force will be equal to the direction of the r cap. If it is in the direction of r cap, if it is in the direction of r cap, it is known as central force system. Central force. It's a central force or central force. We can simply tell the motion of the particle follows a rule of central forces. Okay, fine. So the magnitude of the force will be the magnitude of the force would be the magnitude of the force would be 2m alpha, and it is root of x square plus y square. So this is the magnitude of the force. Okay, and the direction of the force is F cap is equal to R cap. Okay, thanks for watching the video. Hope you do like the session. Do like and subscribe. I'll catch you in the next video. Thank you.